Hi, Assalamualaikum. My name is Putra Ashraf Habib. Today, I'm using my Arduino Uno to do temperature sensing with LM35, switch and LED. Okay, I will answer question number 1. Explain how the LM35 sensor convert temperature into voltage. The LM35 temperature sensor is a precision device that converts temperature into a proportional voltage output. As the temperature increases, the characteristic of the semiconductor material change, leading to a corresponding change in the output voltage. The output voltage can be measured using an analog to digital converter, or we call it as ADC, in a microcontroller or other electronic device. The voltage is then converted into a temperature reading using a simple formula. Question number 2. What is the purpose of the millis function in this project? In this project, millis is used to create a timing mechanism that checks the temperature sensor at regular interval. This is done by comparing the current time with the last recorded time when the temperature was checked. If the specific interval has passed, the program proceeds to read the temperature. Question 3. Why do we use an input pull-up or pull-down resistor with the switch? When a pull-up resistor is used, it connects the input pin to a high voltage when the switch is open. When the switch is pressed, it connects the pin to ground, resulting in a low reading. This configuration ensures that the pin reads high when the switch is not pressed and low when it is pressed. Conversely, a pull-down resistor connects the input pin to ground when the switch is open. When the switch is pressed, it connects the pin to a high voltage, resulting in a high reading. This setup ensures that the pin reads low when the switch is not pressed and high when it is pressed. Okay, for question 4, modify the code to blink the LED instead of turning it on continuously when the temperature exceeds 30 degrees Celsius. For question number 5, implement an additional feature to display a warning message on the serial monitor when the temperature is too high. For question number 6, how would you modify the code to adjust the temperature threshold dynamically using a potentiometer? Question 7. What advantages does using millis have over using delay? First of all, non-blocking operation. The primary advantage of millis is that it allows the program to continue executing the other task while waiting for a specific time interval. In contrast, delay halt the entire program for the specific duration, preventing any other code from running during that time. This can lead to unresponsive behavior, especially in applications that require user interaction or real-time processing. Next, improve responsiveness. By using Millis, the program can remain responsive to input such as button presses or sensor reading. Even while waiting for a timer to expire, this is crucial in interactive application where immediate feedback is necessary. Question 8. Modify the code to display the highest recorded temperature since the program started. Question 9. Modify the code to include a buzzer that turns on when the temperature exceeds 35 degrees Celsius. Question 10. Modify the code to turn on the LED only if the temperature remains above 30 degrees Celsius for 5 consecutive seconds.